We are starting our new chapter, that is thermochemistry, chapter number 7 of your book. What is thermochemistry? Therm is basically the term that is for heat, and heat is a form of energy as we know that. And this is basically the thermochemistry is basically the physical chemistry. The branch of chemistry which deals with the study of a heat changes during a chemical reaction. As we know, there are many changes takes place during a chemical reaction. When there is a change related to heat, that study of change of heat in a chemical reaction is called thermochemistry. Therm means heat, and when we are discussing about the change in a heat during chemical reactions, during chemical reaction, that change of heat, the study of that change of heat is called thermochemistry. And in thermochemistry, we discuss about the quantitative effects, quantity of the heat loss or heat gain during a chemical reaction. While chemical reaction takes place, there is two things happen: absorption of heat or releasing of heat. While you are doing chemical reaction, two things happen: is the heat is absorbed or is the heat is released. When the bond break, when you are breaking the bond, heat will absorb. Heat will absorb. When you want to break the bond of a compound and divide it, then you have to give the heat to the system. Provide the heat. That type of reactions are called as basically endothermic. Endothermic. In endothermic reaction, heat is absorbed by a system. Endothermic reaction. When you are bond, this is for bond breaking. When you want to break the bond, you have to absorb the energy. But when you are making the bond, if you want to make a bond, for example, you want to make a bonding between hydrogen gas and oxygen gas to make a water, that means you are making something. You are making a water. So in this reaction, you have to, or system have to release the energy. System has to release the energy while system is making a bond. If I do the reverse of this reaction, from water to hydrogen gas and oxygen gas, I am reversing this reaction, which means I am breaking this bond. I am breaking this bond. If you are breaking the bond, then energy will be absorbed. And if you are making the bond, energy will release from the system. While making something, energy will release. While breaking something, energy will add. Energy will absorb. So in a thermochemistry, basically we discuss about the heat loss, heat gain. Basically the whole thermochemistry revolves around the heat of the reaction. What is the heat of the reaction? The amount of energy that is absorbed or released in a chemical reaction. That is the heat of the reaction. That how much energy will be absorbed or how much energy will be released during a chemical reaction. That heat of reaction is basically the main concept of this thermochemistry. When there is a changes in a heat, two things takes place. Due to the change of the heat, physical changes takes place or a chemical changes take place. These changes could be endothermic reaction or exothermic reaction, as I told you about this. Can you tell me about the units of the reaction, units of the heat? As I'm saying, heat is a energy. So energy having units, joule or a joule. Yes, kilojoule. It could be calories. So heat having these different units to measure. As I'm saying, the changes are endothermic or exothermic. If the change is, for example, if the change is exothermic, so which means the reaction in which energy is released, the reaction in which energy is released in the form of heat. The net heat release. We are discussing in exothermic reaction the net heat, how much energy is released. It doesn't matter that which amount of energy you provided in the start of the reaction and how much energy left at the end of the reaction. You just have to discuss about the net result. You have to tell the net heat release during a chemical reaction. For example, in a starting low amount of energy is releasing, later and later the higher it is increasing. After some time the more energy will release, and after some time further energy will release. So you have to just discuss the net heat release during a exothermic reaction. It doesn't matter initially it having a low energy, it having a high energy, at the end it having a low or a high, doesn't matter. Just you have to tell about the net heat release during a exothermic reaction. And exothermic reaction is basically a reaction in which energy is released in the form of heat. What is the effect of exothermic reaction on surrounding? For example, this is a system. This beaker, for example, this beaker is set as a system. Here you having a, for example, water in, and this water is a system. This walls of the beaker is considered as boundary, and the air outside this beaker is considered as surrounding. This is surrounding. So what is the effect of this heat release on these three things? During exothermic reaction, as I am saying, energy will release. Energy will release. The temperature of the system rises and heat moves out to the surrounding. Then temperature of system falls again to the room temperature. This system having a high energy, while exothermic reaction takes place, this system release its energy to the surrounding. Now surrounding having high energy and the system's energy will fall down. In exothermic reaction, system will lose its energy, release its energy, and the system's temperature will fall down. The system's heat will fall down, and the heat of the surrounding will increase. And as I told you, exothermic reaction is the reaction of the bond formation. While you are forming the bond, exothermic reaction takes place. Exothermic reaction release the energy. When there is a release of energy, the sign for the exothermic reaction is minus. The sign for exothermic reaction is minus. In endothermic reaction, what is happening in endothermic reaction? In endothermic reaction, heat is absorbed by the system from the surrounding. This is the surrounding and this is a system. So when the system absorbs heat from the surrounding, this is called as endothermic reaction. And endothermic reaction is basically the bond breakage. This water molecules absorb energy to convert into hydrogen gas and oxygen gas. So if you want to break the bonds, you have to add the energy in a system. Add the energy. That's why endothermic reaction having a positive sign, because the net heat absorbed is positive, and in this the net heat release is negative. If I'm giving you some examples of endothermic and exothermic reaction, so you can see here examples of endothermic reaction. For example, endothermic reaction, if you are breaking the water molecule into hydrogen gas and oxygen gas, this is a endothermic reaction because you are breaking the bond. You are breaking the bond. Exothermic reaction, for example, you are making the bond carbon plus oxygen combining together and making a carbon dioxide. So you are forming the bond. So the reaction is exothermic. The reaction is exothermic. Another example, for example, you are here, this is the another example. If you are making water molecule by combining hydrogen gas and oxygen, this is also an exothermic reaction while making a bond, forming a bond. So the reaction is exothermic. The reaction is exothermic. What is the difference between exothermic and endothermic? If in exams, if the question, basically this is not a topic of your ALP, so there is no question asked about this topic in your exams because this topic is excluded from your syllabus. What is exothermic reaction? What is endothermic reaction? The difference between these two are excluded from your syllabus. But I am giving you idea about these two reactions due to the concept, because whole chapter based on these concepts. What is exothermic reaction? What is endothermic reaction? What is spontaneous reaction? What is non-spontaneous reaction? So you must have to know about these two. So well, leave the difference between these two. You got the whole concept, so you can differentiate. Let's move towards the spontaneous and a non-spontaneous reaction. What is spontaneous and what is non-spontaneous reaction? Spontaneous reaction, let's start from spontaneous reaction. Spontaneous reaction is basically the reaction which takes place on its own without any outside assistance. Those reactions which takes place without any external assistant are called as spontaneous reaction. Those takes place without any help are spontaneous reactions. They no need any external force to be takes place. For example, if you want to flow the water from top to bottom, for example, water is present here and it had to move downward. So this water that is at the top will move downward without any assistance. Without any assistance, this water will move downwards. So this is, for example, easiest example of spontaneous reaction. Another example of spontaneous reaction is the flow of current from high potential to low potential. No need any external assistance. Current from higher potential move without any help towards the lower potential. If we talk about any chemical reaction, so you can see here neutralization reaction. Example of neutralization reaction. What is the neutralization reaction? When acid and base react together, this is a base, sodium hydroxide, and hydrochloric acid, this is acid. When base and acid reacts together, they will form salt and water. This reaction is called as neutralization reaction. When in a system there is base or acid, they no need any external assistance to be takes place. If you put in a beaker acid and a base, they quickly react and make salt and water. So in a neutralization reaction, no external energy, no external force, no external assistance is required. Another example for spontaneous reaction is copper sulfate plus zinc. Copper sulfate having a blue color. When you add zinc in it, it will be faded. This blue color will be faded. So this reaction is also a spontaneous reaction. This zinc quickly replaces this copper. Electrolysis takes place. Zinc sulfate will form and copper will remove from this sulfate in a system. This will happen. So this reaction is also spontaneous. No need any external assistance to be takes place. When in a system there is copper sulfate and zinc, zinc quickly replaces this copper and takes the place of copper due to its potential. Copper having a more potential than zinc having a more potential than copper. So that's why zinc take the space or the place of this copper and attach with the sulfate and form zinc sulfate, and copper will be removed as a solid. So these are the examples of spontaneous reaction. If we talk about some journal examples in which you need energy to be provided at the start. For example, burning of coal. If you want to burn the coal, in a start you need to ignite this reaction. You have to just lighten or with a matchstick, you just have to start the reaction. But when you start the reaction, then you no need to provide further heat. Just once you have to ignite the reaction, after that, the burning of coal will be spontaneous. In the same way, if you are burning hydrocarbons, in a start, you just need to provide a little bit heat. After that, you no need to provide heat, the reaction takes place spontaneously. Next is non-spontaneous reaction. What are non-spontaneous reactions? Non-spontaneous reactions are those reactions which need external help, which need external aid to be take place. In this reaction, you have to provide some assistance to the reaction. Without your assistance, the reaction will not take place. Non-spontaneous reactions. In a non-spontaneous reaction, if you take the example, the easiest example, that you want to flow this water upward. If you want to flow this water upward, so you need some energy. For example, from the lower ground water tanks, you want to move the water upward, so you place some motors, so that motors will pump the water upward. So these type of reactions, these type of processes are non-spontaneous. They need external assistance to be take place. If you want to transfer the potential from a lower to a higher side, then you need assistance, because from lower potential you cannot flow the current always from higher potential towards a lower potential. If you want to reverse this, you want to move the current from lower potential towards higher potential, then you need external assistance to do this reaction. If you want to transfer a heat from a cold body to a hot body, can you do this? For example, there is a cold body, you want to take the heat of that cold body, and the outside environment is itself hot, and you want to take the heat of that cold body, you need external force, external assistant to do this reaction, to do this process. In the same way, here you can see the reaction of formation of nitrogen oxide. If you want to form this nitrogen oxide, you have to provide the heat to this reaction, lightning to this reaction. Otherwise, this reaction will not take place. So those reactions in which you need external energy to do the reaction, those are called as non-spontaneous reaction. Non-spontaneous reactions are endothermic, and spontaneous reaction are exothermic, but not always. But not always. I am saying this again, but not always. Spontaneous reactions are exothermic, but not always. Sometimes spontaneous reactions are also endothermic, like, like conversion of ice into liquid. If you place ice, that ice will convert into liquid without any assistance. That ice will convert into liquid without any assistance by absorbing the energy, from the surrounding. So this reaction is spontaneous. Conversion of ice into a liquid is spontaneous reaction, but endothermic. So you generally say that all the spontaneous reactions are exothermic, but some of them are endothermic. Some examples are for endothermic. Not all the reactions are exothermic. Spontaneous reactions are exothermic, but some of them are endothermic. For example, as I gave you the example of ice. Another example of spontaneous reaction that is endothermic spontaneous reaction is the process of evaporation. If you want to convert the liquid water into a water vapors into a gas, This reaction is the reaction of evaporation. This is a spontaneous endothermic reaction. Liquid water will heat, absorb heat. Absorb heat means endothermic reaction absorb heat and takes place without any assistance. Another example for endothermic reaction is dissolution of NH4Cl, ammonium chloride. The dissolution of this ammonium chloride is also spontaneous but endothermic. This is also an spontaneous reaction but endothermic. It will absorb heat and convert into its ions. Cl minus. Clear? Next, these both topics, endothermic reaction, exothermic reaction, spontaneous reaction, non-spontaneous reaction, are excluded, are not included in your syllabus. I'm just giving you the general idea that what these reactions are, ताकि आपको आगे की बातें clear हो सके. The main topic of our ALP syllabus is system, surrounding and state function. This is the first topic that is included from your this chapter. What is state, surrounding and state function? What is system, surrounding and state function? So, for example, this is a flask. This flask having a zinc plus copper chloride solution. This is a system. The thing that you are observing, the thing that is under consideration, the thing that is in your observation or in your concentration, or the thing that you are going to study is called the system. You are going to study the reaction between zinc plus copper sulfate. So this is the system because this is in observation. This is in a consideration. So this is called as a system. What is surrounding? Everything outside this system is called the surrounding. The air, the space, everything outside the system is called surrounding. System having some boundaries. That boundaries could be imaginary or could be real. This flask lining is basically the boundary for this system. This is the real boundary. Sometimes there is an imaginary boundary for the system. So boundary could be imaginary or real that separates the system from the surrounding. So these things are very important to understand the heat loss or heat gain or the change of the heat during a thermochemistry. System, surrounding and the boundary. What is state function? What is state function? The very important thing that is state function in thermochemistry is, first we know what is the state of the system. State of system means the conditions of the system, initially and finally. Initial conditions and final. Initial conditions means before the heat loss or gain. Those conditions are called initial. For example, volume 1, temperature 1, pressure 1, initial temperature, volume that is initially T1, temperature that is initially pressure that is initially. These are the initial conditions of these are the initial state of the system. Then the final state. Final state means V2, volume, that final volume, T2, final temperature, P2, final pressure. So these are the final states of the system. So basically the change in initial and a final state of the system is called as the total state of the system. The variables of the system initially and finally are the state of the system. Variables that are include initially, variables that are at the final of the reaction, at the end of the reaction, are the state of the system. Are the state of the system. What is state function? State function is basically a macroscopic property of a system which has some definite values for initial and final state and is independent of the path adopted to bring about this change. State function are those values of the system, are those definite values of the system, definite values of the system which do not depend on the path of the reaction. Change in a volume of the system do not depend upon the path. This is a state function. Temperature of the system initially and finally do not depend upon the path of that temperature. Do not depend upon the path. By the path the temperature is changes. In a state functions, there is a definite values. Those values do not depend upon the path. For example, volume, this is a state function. Temperature, it is a state function. Pressure, this is also a state function, do not depend upon the path of the reaction. Enthalpy is also a state function. Internal energy, enthalpy is represented as H, delta H. So change of enthalpy is also a state function. Internal energy, delta E, is also a state function. Pressure is also a state function. Volume is also a state function. Change in temperature is also a state function. So those definite volume for initial and a final state are independent of the path. That how internal energy change, what is the path to change the internal energy of the system doesn't matter. This is called as a state function. Doesn't matter which path is adopted by the system to change the internal energy. Change in the enthalpy, change in the heat content, doesn't matter which path is adopted by the system to change it. This is called as a state function. If there is a change in a volume initially and finally, doesn't matter which path is adopted by the system to change the volume. This is called as a state function in thermochemistry. When we are talking about thermochemistry, state function is a very important term. A state function is always represented as a capital letter. If you are talking about the state function, you have to write the capital. E is a capital, H capital, volume V capital, temperature T capital, P capital. So state function is always written as a capital letter. State function is basically the definite values for initial and a final state and is independent of the path. Doesn't matter which path is adopted by the system to change the volume, to change the temperature, to change the pressure, to change the enthalpy, to change the internal energy. Doesn't matter which path is followed by the system. That is called as state function. And state of the system is the initial and the final conditions of the system. Always remember this. State function is written as a capital letter. Work and heat, these two terms are not a state function. Work, we will talk about the work and heat in this whole chapter. In thermochemistry, work and heat, these two are not state function. They depend upon the path. Work is depend upon the path and heat is depend upon the path. So remember this, work and heat are not state function. So while you are writing the symbol for work, so you have to write small letter W, not capital letter. This is wrong because work is not a state function. If you are writing about the heat, so you have to write Q. Heat is represented as a Q. Temperature is represented as a capital T. Heat is represented as a Q. So while you are writing heat, symbol of heat, so you have to write small letter. If you write like this, it's wrong. Okay. So heat and work are not state function.